Why am I starting this session? Because oftentimes I've been doing this job for a while, and people don't see the innovation. They underestimate the effort that we need to input into this innovation, which is smart building, smart factories. So I'm going to take the real case of the renovation of a castle, which means you have old castle, you want to make it brand new with brand new technologies, smart home inside, and the cloud technology, but you don't know where to start. And the usual architecture of a castle renovation has to be readjusted. We will see how to do that. So digital innovation is mainly and mostly invisible. So because it's invisible, how the big bosses and the manager will say, okay, I will invest $500,000 in this project, in this castle, in the renewal of this castle. For example, if I take the example of a smart home is still okay because we can see the innovation inside. We will see lights with your remote control with a mobile phone. You will touch your mobile phone, turn on the light, turn off the light, check the heat. How does that work? So it's quite easy to understand. This innovation is visible. And if I take the analogy of Tesla, how can we see the innovation of Tesla? On one side, you see the car, the external car. It's new design with sometimes the door that opens like wings, like a flight. The inside, you've got a massive iPad that you can play with. This is the front and the visible part. The invisible part could be the back office, the back end, where you can control fully the car. So last night I had a dinner with my friend, and they have got a Tesla. They show me what we see here, the remote control. He can control the car from far away. It's not a problem as long as we have got internet. It's quite amazing. If we analyze a little bit this scenario, we will see as I was saying, on the visible part, on the top side of the iceberg, the visible element, it's small, it's the car. You've got the tablet. So it's the wow effect. It's wonderful. And we shouldn't forget and underestimate the back end, the battery recharging, the remote control, and a lot of people working on the back end before people could enjoy the car. So if I take the analogy of a smart factory, so I took this example from Hanover Mess. This is the showcase, nearly worldwide known showcase. People will see, oh wow, that's wonderful. This robot can lift a car. That's probably innovation, but it's not really an innovation. In fact, we can do that for the last 20 years. So for a car manufacturer, he will not see the innovation of a smart factory. He will say, yes, I've been doing that for the last 20 years. I don't see the innovation. And he would be right. You are right, Mr. Big Boss of the factory. You cannot see really easily the innovation. So the first mistake is don't judge a book from its cover. Because if we come back to the car, in fact, here, we don't know if it's what we call Industry 3.0 or Industry 4.0, because the visible aspect of the iceberg cannot tell you what it is. Behind the scene, it's the hidden part of the iceberg. It's how you can determine, it's the only way you can determine if it's industry of the future, sometimes it's called Industry 4.0, or not. So the question is that, how am I gonna convince people to move from a regular renovation of a building to move to new building types, which is a smart building? And I'm going to tell you the answer. Again, the visible element is the remote control for the smart home. So you've got this massive control. You can see sometimes the temperature. It's 22 degrees. It's maybe too hot or too chill. So my colleague last night, he was playing with his car. He said, "Okay, let's turn on the heat on my car because it's cold and I want to enjoy my car. When I arrive, it's warm." So it's visible element. Everyone could understand that. For a smart castle, it's different because it's not just a house. It's a house, but you've got, when you want to renew with modern elements, you've got the elevator, you've got electric stairs, you've got sometimes electronic heaters that calculates and predicts how many people will be in the castle for the next 5 days. So you can heat up a little bit more. So it's not just a matter of turning on and off lights. So that's the visible wow effect. Behind the scene, it's an entire new technology that is usually underestimated. Now, if we consider if we try to see under the sea level, the invisible part, oftentimes we call or we put forward the notion and the notion of digital twins. To be honest, 5 years ago, Microsoft and Schneider presented me this notion of digital twin in Orlando, and I said, "Wow, that's wonderful in a slide in PowerPoint." But I don't see the point. It was at that time very difficult for me to understand what is the innovation. And the innovation, I'm going to try to present you the innovation without bringing you into the smart building and the smart castle. And the innovation will start with one terminology, which is the ontology. Ontology, sometimes we can call that taxonomy. And if you still don't know what it is, it's a matter of putting words into elements. For example, I'm going to take example. Here you see windmills. So in the windmills, how can we describe worldwide a windmill? You've got I forgot the name of it. You've got the helix, maybe let's call that helix. You've got the helix, you've got the tubes, and inside the tubes you've got a door. Inside the door you've got electric wires, and so on and so forth. So imagine that you describe this, but for the entire building and the entire castle. That starts to be very messy. It starts to be very messy, especially if you talk with someone on the other side of the planet. He will arrive on your project and you will talk, one will talk Chinese, the other guy will talk French, the other guy will talk English. So we have to have a one universal vocabulary, like a massive dictionary, and we use the same. So that when we create a smart building or renew a smart castle, we will see the visible part and we put the proper words. It sounds stupid, but it's a matter of putting words and how we organize words, how they are related together, and how those words can be stick into the reality. For example, I've got the door here, I put the word door, and when I open the door, I have got sensors that can say door open. So to organize all those massive information and to map this information into the reality, we have got this notion of digital twin. I hope this is a better explanation, and I will show you some demos later on to ensure that you understood that. If you understood that already, so please forgive me, because I'm going to repeat a little bit for the other people, because that's key to understand the next element. So let's scare you a little bit. I was saying words like door and escalator and so on and so forth. You will see, I'm going to put a laser dot here. You will see what we call a domain. In computing, it's important to decompose the the project into what we call a domain. A domain, for example, a building has some relation. So the building, inside the building, you've got, for example, the level, the story. So for example, here I call that a level. Some people, they will call that a story. And that's a good opportunity to call everything the same way worldwide. So inside the building, you've got a story. Inside the story, you've got a space. Inside the space, you've got a subspace. And building A, building B, building C, they all are standing on the site A, B, C. So you can see that it's like a Russian doll. So we got a big, smaller and smaller and smaller. And that makes this mess. If you look at from, let's say, if you zoom out from the Earth, you've got the Earth. You zoom in, you've got the, for example, the continent. You zoom in, you've got cities. You zoom in, and so on and so forth. You zoom in up until you reach the microphone, and up until you reach the electronic sensors. So imagine that for an entire castle. That's way more difficult to do a smart castle than a smart home. Smart home, it's the visible element. You put, you buy the light bulb. You buy the application that goes with that. You turn on and off. It's easy. When you deal with smart castles, smart buildings, smart cities, smart factories, it's really complicated. And that's why people, they will still play with Legos. When they go to presentation, they play with the Lego. Yeah, this is a smart building with Lego, smart factory with Lego. For in the reality, obviously, we cannot put Lego into production. You don't live in a Lego house. So what's the point in presenting Legos? So I'm going to show you techniques to convince people and to show the innovation and go beyond those Lego aspects. And I'm going to present you some tangible, so you can touch the complexity. So the big picture of what I described you, if I have to summarize, is this picture. You have a windmill for a smart city, for example. You have a castle, and for example, the customer I was working with, he just don't have a castle. He has a charging bank for a Tesla. He has got windmill. He has got solar energy. He has got the energy from the earth. So it's very modern, brand new technology that has been created to use the heat of the earth. It exists for dozens of for decades, but he has got new ways to extract the heat without damaging too much the oil, the soil, the earth. So that's a massive picture. And the common element of this in the middle, we can see that there's a common part with the cloud. So that's why also I'm here today. It's everything has to be connected into the common part is the cloud. So we have got this notion of digital twin. Here we can see also a factory, because when you cook, for example, in the castle, cooking is like a mini factory. You have to organize and to connect various things. I didn't mention the point of this castle. This castle is a bit like the idea of the castle owner is to be like Uber, which means he will put this castle and you will nearly have no employees. So everything will be automated. It's brand new ways of creating castle, and it's a Zen castle. So you just pay the castle, you go there, you enjoy yourself, you nearly don't meet any people. So it's a Zen kind of a castle. So one of the tricks is to make visible the invisible. The solution that we know is to present use cases. So I'm going to choose one use case just to show you how can that work. So that use case, it's very important to analyze this use case through user experience and without talking about technologies. So again, ideally, don't talk about technologies, just present the user experience. Let's take an analogy. For example, my grandma, she will see me using this very old and antique phone with a cable, and I will answer the phone. The grandma says, "Yeah, that's cool, wonderful phone." And now suddenly, I will cut the wire, and I will be in the situation where I have got a mobile phone. So no more wire. It's very similar in a way that my grandmother, and my grandfather, he will just say, "Okay, yes, why not? There's a cable. I just cut the cable," and it's very similar in terms of user experience. It's nearly the same, except that obviously you can put the mobile phone in your phone and go on the other side of the planet and still phone. So that could be a little bit amazing for my grandfather and grandmother. But that's nearly the only thing that differs from the old mobile phone, the old phone and the new phone. But behind the scene, the entire technology is totally different. On one side, you've got a real cable that goes from my room to the room of my grandfather on the other side of the country, for example. That's a real cable. And on the other side, you've got sometimes a phone that connects through 3G, 4G, sometimes through the satellites. So it's totally different. You've got inside some chips. You've got some chips, some computer inside. So it's, again, totally different. But from the outside, from my grandmother point of view, it's very similar. Very similar. For example, Tesla. I will take the example of Tesla. How can we, as non-expert, can we present the Tesla way of making things visible, for example, in a factory? When you say, okay, or in a smart kitchen. So if we do a demo, like the one I'm going to present here, here, what we see is nearly nothing impressive because that's a remote control. And we press the remote control, and if we zoom in a little bit, we will see a light that turns on and off. In fact, it's a fan. It's a fan that turns, and it emits also a light, a blue light. So we just turn that on and off. Easy enough for my grandmother. She said, "Yeah, what's the point? Yeah, I can do that for since the invention of electricity, you can turn on and off the light." But the difference is that I don't have any cable. I don't have any cable at all. And not only I don't have any cable, but the information from the mobile phone, when I press the button, it goes through my 3G, 4G, 5G to the operator, mobile phone operator. It goes to Azure, to the cloud, somewhere in France, in the south of France. From that, it does some computational information are gathered. For example, I can gather, you authorize this button, pressing this button only if it's not raining for some reason. If it rains, you don't allow the fan to go on and off. You have got that in smart homes sometimes because you don't want to put the curtains down when it's too windy. It's dangerous. So you try to turn that on, and the system will say, "No, sorry, I cannot do that." Okay. So the use case seems very easy. The complexity of doing that is very complex. It's at least 6 months to 1 year of research and development before doing that. That sounds stupid, but just pressing this button, as we see here, it is very complicated. Why is that complicated? Because in a smart castle, for example, or here in the smart factory, as you know, there's a lot of hacking around. There's a lot of cyber attacks and ransomware, which means this smart castle has to be totally protected like a bunker. which means also that you don't have internet inside. On the if I zoom in a little bit, inside the smart building or the smart castle, you don't have internet. As a customer, also it's good for me because I don't want internet. I want to go in my castle, enjoy the zen, and I don't want to be annoyed by Wi-Fi and this and that. So no Wi-Fi, no internet. But you will say, how can I turn on and off the light when I don't have internet? That's the entire complexity. The other complexity is, again, with the cyber attacks. We have to be here with no internet and cyber attacks proof. So we have to use very specific standard communication standard to vehicle the information in a safe manner with highly secured ways. You can ask me questions about that later on in the Q&A if you like. Also, at some point, you will say, yes, but how can I send information to this smart castle if we don't have internet? The only element which has got internet is this one. This one is behind a firewall, and this is, I'm not going to enter into details, but ask me the question later on. But there is a firewall that is configured in a very secured way that can receive in a very specific condition some information inside. And this information inside will flow up until the fan that is blue here. So again, if I take the analogy of my grandmother that doesn't understand the difference between the old-fashioned phone and the new mobile phone, the gap is very similar. Here, when I just press the button, it sends the information. It's just a hell of a complexity, and at least 30 technologies has been put into this presentation. It's live presentation, it works, it's deployed into production, into factories and into castles. And now I'm going to show you the full picture of that. So at the moment, I just show you one button. It's as a grandmother, it's easy. You just press on and off. Now I'm going to show you some use case of complexity, and I will always focus on use case and user experience. I will not talk about technology. So that's my aim. I'm checking the time, 33. And I'm going to present you a video. Okay. So in this video, the guy with the helmet, it's me. So the guy with the helmet, let's assume I'm on the other side of the planet in China and in a Chinese factory here. And the boss, Louis, he's in France, he's French, and he is monitoring the factory or his castle from far away. And he has got just a mobile phone or a computer. So it's thousands of kilometers apart. So obviously you wouldn't see in this video. So we put everything into that space, but imagine this is totally separated. So let's start. What we do here is to monitor the smart building here, the smart factory, using indicators and with real devices. Real devices there's no Raspberry Pi, there's no gadget, there's no Lego. That allows us to present and to focus on the monitoring of the equipment. As the boss, as the owner of a hotel, you just want to know at the end of the month or at the end of the day how much you will earn. You don't care about the rest. If the rest, well, If the rest is totally awful and that doesn't work, it has got impact on the final indicator. So if you look at just this indicator, and if it's good, it means everything underneath is good. So this indicator is presented on this big screen here on the left. Let's carry on. It's real-time monitor on the big screen, and the boss is doing some boss stuff. He's doing billing and something like that, and he has got also, this boss has got the visibility of the entire of the other sites of the other castle worldwide. How am I performing in Asia? How am I performing in France and in the US? Okay, that sounds good. Indicators are good. So I'm earning a lot of money. Wonderful. I don't have to care about the rest because he has got many managers underneath him. And now we're going to create some problems. So what can we do if we have got some problems? One of the problem is that, okay, let's put and drop some cardboard box. Let's say the delivery of your food in your smart kitchen. The delivery of the food and the supply chain has been broken because some cardboard box are dropping down, just like this example. But the problem is that as a cook, or here in the factory, I don't have, it's orange alert. It's not mega blocking. So I carry on. I don't pay attention to this orange alert. So I carry on working or cooking. And I just see, okay, there's a little problem, but that's not too important. Let's carry on working. The problem is that the house and the smart building will defend itself. It will say, okay, Vincent, it's not your job because you carry on cooking, you carry on working. It's my job as a smart building, as a smart factory, smart house, to send the information to the big boss. He will take actions. So the big boss will receive something on his phone. The phone is ringing, and he will check his mobile. Oh my God, orange alert. So the boss, I'm removing the hat. Orange alert, I'm going to check on my various dashboards. Oh yes, it's very important, this problem. It's not only orange alert, I'm going to raise a red alert. So that's what he's going to do. So he got alerted. He's going to do some verification. He sees that the indicators are really bad. So he's going to launch the red alert, pressing in a one click, like the remote as I presented. Red alert. Red alert sends immediately information to the factory or to the smart building, and here it activates a fan. So voluntarily, the fan is here because I put a bigger fan, because the one you saw, it was too small, so I put a big fan. Just to show you that the information travels at the speed of light. It goes into the 3G, it goes into Azure, it makes decision into Azure, the decision comes into the smart factory, the smart building, it flows into through the firewall, it goes into a zone where you don't have any more internet, but still it works. It's highly secured. You can try to hack that. I'll be glad if you manage to hack and to make that and to break the factory. And suddenly now it's no more orange alert. It's red alert. So now I'm alerted as an employee. I said, my God, red alert. I have to do something. So I stop here. I stop the button. I press the emergency button to warn everyone that it's red alert. And I'm going to fix the problem. Fixing the problem means, okay, I try to identify why the supply chain has been broken. I fix that. Okay, I put the cardboard box back to normal. I unpack the cooking ingredients. and everything goes back to normal. The problem is that I just fix what is visible. I don't understand the root cause of this problem. Very often we call that root cause analysis, RCA, root cause analysis in a smart hotel. So where this smart hotel is very like a factory, everything has to be in order, the supply chain has to be done properly. It's not like a smart home where, okay, I want my TV on, I press the TV, yeah, I'm the boss and I control everything. I want the music, I put the music. So the smart home, smart hotel, smart factory, everything has to be orchestrated by a big brain. And it has to take decisions. But the big brain will be influenced, and obviously it has a big boss, a human boss. The human boss has to understand rapidly what's going on. Usually, what happens in a hotel or in a factory, after you have got a problem, you fill a form manually. You fill in the form. We will present that in a few seconds. Here is the form. So the problem report form, I present, okay, the cardboard box dropped down because this and that. It was critical because the cook couldn't cook and deliver the food in due time. So we have 25 unhappy customers and this and that. But to be honest, and we did some polls, many people that just put stupid things in the forms because they want to get rid of that. They said the statistics showed that they spend 50% of their time filling the forms. Sometimes, so 50% of the time, it's a lot. It's awful for them. It's a nightmare. So they just want to, when they finish their job, they just want to leave and go back home. So they don't feel that properly. What the new technology, the invisible technology, allows is the following. We will qualify the problem and tell all those information and replace those manual forms with basic buttons. Why are we going to use basic buttons instead of using a smart tablet or keyboard? Because simply I'm a worker and I don't want to remove my gloves or take a pen or I don't know, take a keyboard and use hydro alcoholic gel for COVID. So you have to soap the hands and it takes a lot of time. It's tedious. So we just use low technology. I repeat, it's where I'm talking about digital twins or something of the future, but we shouldn't forget and underestimate the usage of low technology. Low technology is good also for the planet because here we have got only metallic buttons. So press the metallic. Once you don't want that anymore, you recycle that. It's easy. You cannot recycle easily a smartphone or a computer. So low tech will answer the question, and this low tech will be connected to the new technology and the smart technology. So no more forms. If you have got the buttons, low technology and high technology, just use your gloves, your hands, and press the buttons. So, okay, the cardboard box dropped down because of the supply chain. And if you see, it's a matter of only a few seconds. As soon as I press the button, at the moment you see no reason, you will see something appearing. I press the button, up, cardboard box, cardboard, which means as soon as I press that button in the speed of light, as quick as the speed of light, this information travels on the other side of the planet through the internet, reaches the cloud, Azure Cloud. Azure Cloud takes some decisions, and the decision is displayed on this massive screen for the boss in France. So the boss can understand what happens into one hotel, 3 hotels, 25 castles, and he can take immediate action. He says, okay, let's filter by months. This is a monthly view, but you can zoom in for one day, you can zoom out, and you can take actions immediately. And that's what he will do. the boss on his side will take action and send someone, for example, or he will say, it's the 25 times that this supplier of food is giving me troubles. I cannot make any brand. Let's change and let's swap to the other one. Press a button, validate, and go to the other supplier, and the problem is solved. So it's the problem of 80%, 20%. So I'm going to spend 20% of my time, so pressing a button, and that will fix 80% of my problems. So that's how we can do root cause analysis, RCA, in a real time instead of filling forms. And behind the scene, that sounds easy to do that. Again, that's the very same technology that we use for smart building, for smart home, smart factory, and also smart farming. So when you do smart farming, that's the very same thing. I guess I'm reaching nearly the end of my talk. That I hope I made things easier to understand. To understand even easily, even quicker, you have got what you have here is the mini factory. It's 1.20 meters in terms of width, and you can touch it. It's based on a Montessori approach. So as a complement of my talk, in fact, it's best to just touch the thing, play with that. It's a Montessori approach, pedagogical approach, and this approach is deployed into schools at the moment. So I've been teaching school kids and adults. Thank you very much.
Thank you very much. It was amazing speech and really cool video.